Here we'll start with the new chapter, that is an arrays. Now, what is array? So array is nothing but a collection of similar type of elements of a fixed size. Array is collection of similar types of data of a fixed size. Now let's take here 6 as a fixed size, and in this 6 locations you're going to store the data sequentially, like maybe at 25, 13, 43, 8, 7, 27. So all these data what are stored are of type integer, which are stored here sequentially in a continuous memory location. So it may be an integer array. Same way you can have another of 5 elements where you're going to store here 3.5, 4.7, 6.3, 2.1, 7.8. So all these are of type double data type. An array is nothing but collection of similar type of elements of a fixed size. When I specify here in the beginning, okay, while declaration the size as 6, then I can store only 6 elements. Here if I specify the size as 5, then I can store only 5. Dynamically you cannot increase or decrease. Okay, so in the initial stage itself you have to decide how many elements array it is going to be. So here I wanted to store 5 elements double data type. Here I want to store 6 elements of type integer. Okay, that can be done through. Now what is the need of going for arrays? Now let's take one small example. That is, I want to write a program to accept 5 integer values and then to display. Let's write the code without using array. So this is how the code is going to be. So to read 5 integer values, I'm going to declare 5 variables. Let's take here variables as A, B, C, D and E. 5 integer variables have been declared. And now I'll read the values, those 5 values. So we'll display the message to the user, enter 5 integers. So for reading each variable, we'll take a separate scanf, %d, that is ampersand of A, that is the first value has been read. And for reading the second, you can take here again scanf %d ampersand of B. So here I have used 5 scanf statements to read 5 integer values. You can do it with a single scanf, but you have to use your 5%d. So assume that if you want to read 100 values, calculating 100%d in a single scanf, it's going to be too tedious task. The best option is we can have a separate scanf. Then same thing, if you want to display, you can again use your 5 printf statements, /n %d and then display your A value, printf /n %d, that is display B value. Same way one more printf for C, D and E, and then close this. Now just to read 5 integer values and then to display, how many lines of code we are writing here? So 5 printf, 5 scanf, that is total 10 plus additional the for declaration and all. Somewhere around 13 lines of code we are writing just for declaring, reading 5 integer values and then to display it. And how memory allocation takes place in this case. In a random access memory, you have declared here first A variable. Wherever it finds a free space, it will allocate here A variable. So let's take here 2 bytes has been allocated for A. So then you are declaring B variable. For B, again, wherever it finds some other 2 bytes, there it will allocate. So it's going to be a total 10 bytes allocated, but not in a continuous location. Wherever it finds a free space, it's been allocated. That means these all variables have been scattered in a random access memory. This length of the code can be reduced by going for arrays. So what you can do is, instead of declaring your 5 different integer variables, you can declare an array. Okay, you can declare an array. So that can be done like this. to declare 5 integer array, you can just give here int. For every array you got to give a name, so I'll give a name as ARR. Any name can be given, ARR, and here I have to specify how many integer locations you would like to store. So int ARR is the array name, that's an identifier, and I'm asking to allocate 5 integer locations. So what it does is, it will allocate in a random access memory continuous 10 bytes. If each integer is occupying 2 bytes, then it will allocate here a total 10 bytes, and that also it's going to be continuous, not scattered in a different place. Okay. If there is no free 10 byte space in a random access memory, then it will give an error message. Okay, it is not going to allocate 2 bytes in one place, another 2 bytes in another place. That is, it's not going to do it. Arrays are nothing but continuous memory locations. Sequential memory locations are being used to store a similar type of value. So let's see what happens in this case. Now when I give an int ARR of 5, 10 bytes has been allocated for storing 5 integer values, and for all these locations the name given is nothing but ARR itself. Then how do we identify this each location? So this each location is identified by an index number starting from 0. The first location index number is 0, the second location index number is 1, the third is 2, 3, 4, like this. Now if you want to store any value in this first location, then you got to give the array name. The array name is nothing but here ARR. Within square bracket you have to specify its index variable, index number. That index number is 0. So ARR of 0 is equals to, if I give here 25, then the 25 will be stored in this first place. If I give here ARR of 3 is equals to 43, then in the fourth location that the 43 will be stored, because index number of fourth location is nothing but 3. So ARR of 3 equals to 43, it will store 43 in this index number 3 location. So that's how each location is identified by a separate index number, and for all the locations there is a single name given assigned, that is an ARR. Let's rewrite this program using an array. So let's see how it is going to help us using array. So in the program I'll declare here ARR of 5 integer locations. I want to store 5 integer array, so I'll declare here ARR of 5. Plus I'll declare one more variable, that is an I, that is to generate this index variable 0, 1, 2, 3, 4. Okay. So here we'll display the message to the user to enter 5 values, enter 5 integers. Now you can read it by giving here scanf %d ampersand of a of 0. Then if I give 25, the 25 will be stored in the first location. Scanf %d, that is ampersand of a of 1. Then if I give 13, then 13 will be stored in the second location because its index number is 1. And scanf %d ampersand of a of 2, a of 3, a of 4. Like this I can read the value. Same way you can display it. But if I do this, then there is no difference between the previous example and this. Only difference is here you are given different name, whereas here I have given ARR of 0, ARR of 1 and ARR of 2, like this. So that means you will be having, even in this case, 5 scanf statements and 5 printf statements. That can be avoided when you go for an array. So when it is an array, you need not do this job. So what you can do here is, to generate this 0, 1, 2, 3, 4, you take an for statement where you initialize your I value equals to 0, I is less than 5, that means it will go up to 4, and then I plus plus, and here you can use a single scanf statement by giving scanf %d, that is ampersand of ARR of, instead of giving 0, 1, 2, 3, 4, you give your ARR of I. So you can give your ARR of I. That is, first time I value is 0. When I value is 0, scanf ARR of 0 it takes. If I give here 10 as in data, If I give it A of 0, 0, when it is reading your ARR of 0, and if I give the data as in 10, then 10 will be stored in this first location. And next time again it will go back and increment I value. I is going to be 1. 1 is less than 5. Again scanf ARR of I. So if I give her 20, then ARR of I value is 1. So ARR of 1 location value is going to be 20 here. Same way you can read your 30, 40 and 50. So with only one scanf, writing one scanf, we are reading all the 5 integer values. Same thing for displaying all these 5 values. You can take one more loop. I equals to 0, I is less than 5, and then I plus plus, and you can give a printf /n %d, that is an ARR of I. So it will display our ARR of 0, ARR of 1, ARR of 2, so like that all the 5 elements value will be displayed. So I value is 0, so 0 is less than 5, so ARR of 0 value is displayed, that is 25. Next time I value is going to be 1, ARR of 1 is going to be 13, so like that all the values will be displayed. What is the difference between these both? How many lines of code we have written here? 1, 2, 3, 4, 5, 6, 7 lines. 6 lines of code we have written. Whereas here we have written around 13 lines of code. That's the first thing. Second thing is, now in this, when we don't use an array, if we go for this concept A, B, C, D, and if I want to read 100 integer elements and then to display, then I have to declare here 100 variables. Second thing is I need to use your 100 scanf statements and 100 printf. So that means when your number of value increases or decreases, naturally your number of lines of code also gets changed. That is, if I want to go for 100 values, then minimum somewhere around 202 lines of code you got right. 100 for scanf, 100 for printf. So another 2 more lines for displaying message and declaration. Whereas in case of arrays, if you want to read your 100 elements, then in the main program, while declaring an array, you can declare this as 100 elements. So you can declare your ARR of 100 and enter 100 integers. And here what you can do is, instead of giving I is less than 5, you can just change it to I is less than 100. So you can give her I is less than 100, and same way here also you can give her I is less than 100. So we have changed this program from reading 5 integer values to 100 integer values and then to display. Whereas here, if I go for this technique, we are not increasing the length of the code. We have not added any extra lines. The same program, just by changing the values, it's reading here 100 elements. So that means what happens is the index number will go from 0 to 99. 0 to 19, and that's going to be a continuous memory location, not scattered in different places. It's going to be continuous. So if the number of value changes or reduces, the length of the code will not get affected. So managing a similar type of datas, okay, similar type of set of datas becomes easier when you go for arrays. It's very difficult when you use different variable names in this fashion. Okay, so that is why we go for an array. So with this example, I think you have understood what is array and what is the use of going for an array.